Okay, now consider another problem. A cube of side 30 mm is resting on HP with two faces equally inclined to VP. A circular hole is drilled through the center of the cube such that axis of the hole is perpendicular to VP. Draw the development of the cube. So this is a question. In this question, a cube is resting on HP with its face equally inclined to VP. So somewhat like this. A cube is resting on HP with face equally inclined to VP. Suppose this is a cube which is resting on HP, with faces equally inclined to VP. Give name this A, B, C, A, B, C, D, then P, Q, R, S. Suppose this is the case. Now, a hole is drilled such that the axis of the hole is perpendicular to VP, and the hole through the center of the cube. The hole should pass through the center of the cube such that axis of the hole should be perpendicular to VP. So that there is only one way I can drill the hole, say like this. I can drill the hole like this way. This is a way I can drill a hole as per the question. Now the axis of the hole should be perpendicular to VP. So that's why I need to draw the hole like this. So in front view you should see the hole. Top view you cannot see the hole in top view if you draw in this arrangement, because the question is given like that. Now we have to develop the lateral surface of the cube after drilling this hole. This is the case. Here we can draw that. Draw XY line. The square, first top view will be a square and sides of the square should be equally inclined to VP. Just put your protractor here, take 45 degree. So this is the top view of the cube. You have to name it. ABCD is the top face, bottom face P, Q, R, Yes. Now here you have to draw the front view as well. Here it is a front view. Name it A dash, P dash. This is D dash, P dash. Bottom face is S dash, Q dash. This is R dash and C dash. This is how we complete the simple position of the cube. Now we have to draw a circle through the center of the cube. Take the radius of the circle. Take the radius of circle as 20 mm. No, not 20 mm. At the radius of circle as 10 mm and the diameter of the circle as 20 mm. Take this as 20 mm. Diameter of the circle as 20 mm. Draw a circle accordingly. To the exact center, you have to draw the circle. This is the circle which we drilled through the surface of the cube. After drilling a hole in front view, we can see it like this through exact center. So total height is 30 mm. So 1.5 centimeter. At that point, you just draw a circle with diameter 20 mm, radius 10 mm. Now here, while developing the cube, you will get a rectangle with the side equal to 30 into 4. There is 4 times 30. So that you will get 120 mm as the length of the development and height will be equal to 30. This will be the development of the lateral surface. But we have to represent the hole inside the development. For that, I need to divide the circle into 8 equal parts. Because I need to represent circle in development, that is why I need to divide the circle in the development in this front view also. Divide circle into 8 equal parts. So you can divide the circle into 8 equal parts. Just simply name these points using numbers 1, 2, 3, 4, 5, 6, 7, 8. So that when we divide the circle into 8 equal parts, we will be having 8 points. Now you just check which points cut the edges of the cube. Here you can see this edge DC, only 2 points of the circle in this face cut the edge, this edge of the cube. No other edges is cutting the cube. For that, we have to draw some imaginary edges on the surface of the cube. Say I am just projecting point 1 to the top view, 2, 8 to the top view. Similarly, this one, all these points I just projected into this top view. See, from 1 I draw a perpendicular line to the face of the face AB PQ of the top view. Then 2 8 B is also here. B is already here, no need to project it. Then 4 6 and 5. Now just draw the development. If you know the development, the total length of the development is a rectangle of 120 mm. Now divide, as you know the side, 30 mm, 4 times 30, just draw. Now name it. See, as you know, top face is ABCD. A, see, you can have like this, B, C, D, again A, here it is P, Q, R, S, P. So this is the development of the cube. Now we have to draw the section, the cutting points in the cube, the development of the cube. For that, before that, just draw the imaginary edges in the development. You see, in between AB we have projected an imaginary edge. Here there's 2 imaginary edges in between this AB. Similarly, in between BC also there is 2 edges. We can say this is x1 and this is x2. Just simply name it x1, x2. This as these 2 distances will be same. Here also you can divide this as x2, name it as x2. This is x1. So because from B this distance is same, x2. Here also that distance is same. That is why I am giving same name x2 here. This is x2. This point is also x2. This point is x1, and here it is again x1. So there are 2 x1 and 2 x2 on these 2 faces, AB as well as BC. Now take distance from A to x1. A to x1, just take distance. Just take distance A to x1, and from A you mark it here. Always remember, I am taking this point, I am putting compass here at A. A to x1 take the distance and here mark it here. So I have x1 here. Similarly, if I mark C to x1, will be the same distance. From C I can mark another x1. So I mark 2x1 from A to x1 as well as C to x1. Now A to x2, mark it here. This point is x2 and same will be C to x2. See, with this point you can draw the imaginary edges. these are the imaginary edges that we draw to represent the circle in the development. Now we know there are two circular circle will be in the faces of the cone. This face there will be a circular hole, and behind that another circular hole is also present. So we have to represent that also. Here, if we extend these points, you see, we will get another x1 x2 point here also, so that we will have a circular portion here and here. This two sides there will be circular portions. We have to represent that also. That, say, I can take a to x1 distance. Here I can mark a to x1. This is a to x1, and right here x1, again a to x2. Mark it here. This is x2. x2. Now c to x1. c to x1. This is c to x1 from this. So this is c to x1. Again mark c to x2. This is c to x2. See, you have to remember, this is x1, this is also x1, x2, this is x2, this is also x2, here it is x1. So these are the points. So here also you can complete the imaginary edge on other face, CDA. You can complete. See, now we just simply draw the projectors from the circle to meet the corresponding points on these imaginary edges as well as the real edges. Now we will do that. Yes. You can see point 1 is on x1, 1 and 5. You see, I will get 1 here. So 1, there will be 2 1s here. This is also 1. Now 5 is on another x1. This is another x1. So this is 5. We have another 5 here. 5. Then 3 4. 3 is on x2. 4 is also on x2. 3 here, 4 here. Sorry, not 3, 2. Actually this point is 2, not 3. 2 here, 4 here. Similarly, this portion also I can draw this. 4 and 2. This is 2, this is 4, this is 2 here, this is 4 here. 5 and 1 3. 3, this is 3. This is point 3. Other points 4 and 6. So you know 4 is on x2. Sorry, not 4 and 6. This is 6 and 8. 6 and 8. This point is 6 and 8. 6 and 8 is on x2. So 6, 8, 6, 8. Another point 7 is on this BQ. DBQ. Here. This is 7. This point is 7. Now you can join all these points. So this is the representation of hole in that particular development of the cube. So what happened here is, even though in the actual cube we see this as a circle, after developing it, it will become a stretched circle. The circle will be stretched to form an ellipse. So this two circle will form two ellipses in this development. That is how we draw this particular problem. Watch this problem closely and do it. Thank you.